We're now at the stage where we could be using any one or more of 7 angle properties to find unknown angles in a diagram. Remember, there were 5 angle properties we revised, which you covered before Christmas. And then there are 2 new angle properties that we've just looked at, corresponding angles and alternate angles. So we're now going to apply these in the following examples. So let's look at example A. We've got an angle diagram. We've got an angle of 110 degrees and we've 2 unknown angles A and B. Now again, what we could do first is try to get angle A by using the Z rule, because if we trace over the 2 lines that angle A lies between, like that, this will form part of our Z. To complete our letter Z, we're going to trace over the top parallel line like that. So we've clearly got a letter Z and it contains 2 parallel lines. So remember, that means that the angles inside the Z and at the joints of the Z are the same. They are alternate. So that means that angle A is equal to 110 degrees because of the Z rule. And then we can pencil that in our diagram. Then we can get B really easily, because A and B are angles on a straight line, or supplementary angles, because they lie on the same straight line and they span a total angle of 180. So to get angle B, we're going to subtract 110 from 180. We do it mentally because it's only one calculation that we're doing. So that's just going to give us 70. So angle B is going to be 70 degrees, and the reason is angles on a straight line. Okay, let's look at example B. Again, we've got a complicated looking angle diagram. We're only given one angle of 70 degrees, and then we have 4 unknown angles C, D, E and F. The starting point is always with the angle that you do know. So our immediate attention would be drawn to this triangle here. Now, this is not any triangle. This is actually an isosceles triangle, because 2 of the sides have the same number of dashes on them. So if 2 sides have the same number of dashes on them, that means they're the same. So if it's isosceles, then that also means 2 angles are the same. So it's important at this stage to identify which angles are the same. And we always said to you that you always look for the corner where the 2 identical sides meet, and then you flip over to the opposite corners, and those will be the angles that are the same. So C and D are the same. So we can work out angles C and D straight away. In order to do that, we're going to have to subtract 70 from 180, because angles in a triangle add up to 180. And that will give us the remaining 2 angles, but then we're going to have to divide by 2. So there's definitely more than one calculation, so we need to show our working out. So we're going to start with 180. That's what all the angles in a triangle add up to. We're going to subtract the 70 that lies inside the triangle, and that's going to leave us with 110 degrees. So that's what these 2 remaining angles C and D are. So we now want to get what each of these are, so we're going to divide by 2 because they're the same. So our next calculation is 110 divided by 2. So 2 doesn't go into 1, 1 carries over to make 11, 2 and 11 goes 5, with a remainder of 1, carry it over to the 0 to make 10, 2 goes into 10 5 times, no remainder. So that's what angles C and D are. So straight away we can write down that angle C is 55 degrees and angle D is 55 degrees. And we'll give our reasons as to how we got those. Well, we used angles in a triangle, and we used the fact that it was an isosceles triangle. So angles in a triangle, AIT, and isosceles triangle, IT. And the same for angle D. Again, it doesn't do any harm to pencil the angles into the diagram once we've worked them out. So angle C is 55. And likewise angle D is 55. Okay, so that brings us on to E and F. Now, if we could work out angle E, then F would be straightforward because D, E and F would be angles on a straight line or supplementary angles. So it all boils down to getting E. Now, the way in which we can get E is if we trace over the two lines that it lies between. Like that. And that, we have formed part of our letter Z. To complete the letter Z, I'm going to trace over this other parallel line, like that. So it is a letter Z because it contains two parallel lines. You can see the arrow on this line and then the little arrow on the top lines, they are parallel. So that means angle E and the angle of 70 degrees are alternate because they lie inside the letter Z and they both lie at the joints of the Z. There's a joint there and there's a joint up there. So angle E is equal to 70 degrees because of the Z rule for alternate angles. And again, it doesn't do any harm to pencil it in the diagram, so E is 70. So now we just have angle F to get. Now in order to get angle F, we're going to have to add 55 and 70 together and then subtract the result from 180. So there's more than one calculation, so we need to show we're working out. So we're going to add 55 and 70. So 7 and 5 will give us 12. So that's going to give us 125 degrees. And then we're going to subtract this total from 180 because these are angles on a straight line. Okay, they lie beside each other on the same line and they span a total angle of 180. So 180, subtract 125, and that's going to give us what angle E is. So I'm going to have to borrow 1. Carry over. 10 minus 5 is 5. 7 minus 2 is 5. And 1 minus 1 is nothing. So we're left with 55 degrees. So that means that angle F is equal to 55 degrees. And the reason we got that was we used angles on a straight line. Okay.